Hi, everybody. Let's think about the second part of problem 0, which is using the same pattern to find the probability of something. So here was the problem. Find the probability that an odd number of dice are going to show an even value when you roll them. And then we're going to output a table of those probabilities as you roll different numbers of dice from 2 to 100. So this is a very information-dense set of sentences. There's a lot of things happening in a very few number of words. The most important programmer skill is being able to stop and do whatever you need to do to think perfectly clearly about what something means. So this is a difference maybe between what you need as a programmer and what you've done before in school. Often in school, if you don't understand the question, you ask the teacher. When you're a professional programmer, if you can't think clearly about something, it's up to you to be able to have enough tools that you can think clearly about something for yourself. And so that's what I'm going to teach you. I'm trying to teach you those thinking tools. So the first thinking tool is, okay, what do I know for sure? I know I need to output a bunch of numbers. Let's make sure I can think really clearly about what those numbers are supposed to represent. So what could the 5 represent? What could the 0.49 represent? Going back to the text here, it says we're going to output a table of probabilities when something's changing, when I'm going to roll different numbers of dice. So it seems like this left-hand side probably has the meaning of different numbers of dice. So I could roll 2 dice, and then 3 dice, and then 4 dice, and then so on. Okay, so what if I roll 5 dice? What am I trying to figure out? I'm trying to figure out the probability that I see something in those 5 dice. What's the probability? Let's read the phrase. The probability that an odd number of the dice are showing an even value. Okay, so what does that mean? I said that I'm trying to teach you thinking skills for taking an abstract situation and understanding it. So an easy way to understand an abstract situation is to imagine actually doing it. So you can imagine specific numbers and then ask, what does that mean for our question? So let's pretend I actually did roll 5 dice and I got this, 2, 2, 1, 3, 6. I just made these numbers up. When you do it, you'd make your own numbers up. Okay, so now ask, is this an example of the kind of thing where I want to know, is this the outcome I'm trying to find the probability of? Well, let's read it again. The probability an odd number of dice are showing an even value. So, are there an odd number of dice? Well, yeah, there's 5 dice, but I don't want just that. You got to read the whole phrase. Are there an odd number of dice that are showing an even value? So let's start with showing an even value. Let's see, 1, 2, 3. So I see 2 and 2 and 6 are all the even values. There are 3 dice that are showing even values. Oh, and that's an odd number of dice that are showing the even values. So I would say, yes, I rolled the 5 dice, and I did get the outcome where I'm trying to find the probability that I'll see that kind of thing happen. You could imagine the next time I roll the dice, maybe I get all odds. And in that case, I wouldn't have any dice that are showing an even value. So that would be 0 dice that are showing an even value. And 0 is not an odd number. So that wouldn't be the situation I'm trying to find the probability of. Okay, so let's go to the code. This is the code that we ended with last time. So this is the code that displays the average displacement after taking a certain number of random steps. And we have a method that displays a table. And the way that we get the y value in the table is we have a method that will find an average. And the method that finds the average runs our simulation over and over again and adds up the outcomes and divides by how many. And then the simulation, which is like the action that happens, that was taking random steps. So it seems to me 2 things need to change. We've got to change what's the action, because in this problem, we're not taking steps, we're rolling dice. And then the other thing is we're not finding an average, we're finding a probability. So I think this method needs to change as well. But this part shouldn't change at all, because we still need to display rows in a table where every single row is like a number that starts at 1 and counts up. And then the y values in the table are still going to be, some doubles that are the result of some calculation. Okay, so let's start modifying this. Instead of saying find an average, I'm going to change the method name and I'm going to call it find probability. Okay, here the row numbers represent numbers of dice. So, if I wanted to, I could call it row num, if you think that that's clearer, or I could call it num dice. because now that reads a little bit better. Find the probability, related to a certain number of dice. Okay, so how do I find a probability? I'm assuming that you already know this part. If you don't, check the reference. But the way that you find a probability isn't by adding up the outcomes and dividing. Instead, I need a counter to count how many of the simulations ended with the thing I'm trying to find the probability of. So let's pretend that my simulation is going to return, let's say it returns the number of dice that were even. Remember, I'm trying to find the probability that an odd number of dice are showing an even value. So if I run a simulation that tells me, okay, I rolled a certain number of dice. Let's not call this num steps. Now this is num dice. Okay, so if I'm going to run a simulation where I roll a certain number of dice, and it's going to tell me how many of those dice were even, then what I need to check is I need to see, is the number of even, when I divide it by 2, does it have a remainder of 1? Because this is how you test for things being odd. And so if I do have an odd number of dice showing an even value, I'll add to the counter, because that's the probability situation I'm interested in. And then at the end, I'll return the count divided by the number of trials. Because that's an experimental approximation of the probability. Okay, so why is it complaining here? It says required type is an int, because here I'm saying I'm going to save the output into an int. But it says provided is a double, and the reason why is because my do one simulation returns a double. So now let's turn our attention to doing one simulation. We're not taking random steps, we want to roll dice. So let's do that. Let's change this from num steps to num dice. Here, I'm just going to wipe this totally clean. So I do still want a loop where I'm going to loop up to the number of dice I'm trying to roll. You might imagine that I'm going to save all the die values into a list and then loop over the list and count up how many were even. But we don't actually need to save them. I can have num even here starting at 0, and then I'm going to get the die value. So that'll be math.random times 6 plus 1. So that's now between 1 and 6. And I don't need to save all the dice before I start checking to see are they even. I can just check if it's even right here. So if the die value when I divide it by 2 has no remainder, that means it's an even value. And what that means is that I have one more even die value. So I'm not saving the die values. I'm just rolling over and over again. Each time I roll, I check, is it even? And if it's even, I record that in a counter. So by the time I'm done rolling, I should be able to return the number of evens. So that's it. The action is done. Let's go ahead and do the last change, which was return an int here, because the number of die that were even is an integer. It's not a double. And now I think I'm done. So let's run it, see what happens. All right, so I'm rolling different numbers of die. It looks like the probability is just hovering around 50%, which maybe is a surprise to you, or maybe if you can think clearly about the probabilities, is no surprise at all. You're like, yeah, it doesn't matter how many dice I roll. Anyway, the mathematics of the situation is not what we're thinking about. Instead, we're trying to think about how can we organize the complexity of combining the results of thousands and thousands of trials to answer a question. And so hopefully this is starting to make more sense as you do more problems. I would say do a couple more until you're convinced that you can do it on your own. Good luck.